Good day everyone, welcome to JD's channel. Today, we're going to discuss another topic. Don't forget to like, share, and subscribe for more tutorials. Thank you and God bless. Guys, welcome again to JD's channel. And for today's topic, we will discuss all about shear strain. Ayan, pag-usapan natin ng patungkol dito sa shear strain. So let's get started. So, eto class yung ating pag-aaralan ngayon. So, ano ba yung mga content ng ating pag-uusapan? So, una is, what is shear strain? And second is the sign convention of shear strain. Thirdly, yung Hooke's law on shear strain. And ayan, yung pang-apat, meron tayong problem solving. Okay, for introduction class, an object that undergoes shear stress is one that experiences a tangent of an angle through which two adjacent sides rotates relatively to an initial position. Shear strain measures changes in angles with respect to two specific directions. So, ayan, yung ating shear strain. Ano po? So, ano ba pero ano ba talaga yung shear strain? Ano ba yung kanyang definition, no? So, ang shear strain daw class. So, what is shear strain? Shear strain is yan, ang ginagamit nating class na symbol for shear strain is yung symbol na gamma. Yan. Shear strain is the tangent of the angle and is equal to the length of deformation at its maximum divided by the perpendicular length in the plane of force application. So, ayan. Yan daw yung ating shear strain. It is the tangent of the angle. And also, shear strain is the amount of contortion caused by sliding of planes or plane layers over each other within deformity that can be applied by elongation, shortening, volume changes, or angular distortion. Shear strain can accelerate an object's corrosion rate. Ayan. It is an angular change at some point in a shape. So, yan. Yun yung mga definition natin class ng shear strain. For illustration class, ito, ayan. Pansinin natin, meron tayong, let's say we have this block and then meron tayong applied force sa part na ito. Yan. Okay? So, ang tanong, balance ba siya or not? Okay? So, technically, hindi po siya balance. Di ba napag-aralan natin na pagka meron tayong applied force dito, so magkakaroon siya ng may stress yung ating body na to. So, ang tendency niya, magkakaroon siya ng resisting force dito para ma-achieve muli yung equilibrium, para mabalanse niya yun, manatili sa kanya yung equilibrium. So, anong ginagawa natin class? So, ayan. To maintain the equilibrium of the body, there must be a parallel force on the other side of the body. So, ayan. So, class, yan yung magiging itsura niya. Ano? So, yan. We achieve yung equilibrium niya. Since meron tayong applied force here, so, nagkaroon tayo ng counter force dito para mabalanse muli yung ating system. Ano po? And then class, we also have yung tinatawag na rotational equilibrium. So, and also to maintain the rotational equilibrium of the body, there must be a force on the top and the bottom of the body. So, dun sa example natin, ito yan. Yan. So, class, di ba? Yung una natin is meron tayong force apply dito, then kinounter natin para ma-achieve yung equilibrium. And then class, to achieve the rotational equilibrium of this body, so nagkaroon din tayo ng force dito sa taas at dun sa baba. So, in that way, in that setup, ito po ay nagkaroon na ng rotational equilibrium. Ayan. So there is an angle due to the force acting on a body with a magnitude of tau, which result to the figure below. So ito, ayan, ito class. Ayan, so di ba tanda natin pagka, since ang ating pinag-uusapan is shear strain, so tanda natin na sa ating shear stress, di ba, ayan, to the, dahil sa ating shear force, ano po, na in-apply sa isang particular na body in a certain area, so nagkakaroon siya ng change in angle or position. Ano po, at ayan, yung isang example natin. Ano po, so ito from yung original position natin kanina, which is naka 90 degree. Ano po, so due to the shear force or yung ating shear stress, ano po, ayan, nag-iba siya ng position or ng shape. Technically, nag-iba siya ng shape. Ano po, from square, then, ayan, parang naging parallelogram na siya. Ayan. So, ano ba yung shear strain na sinasabi natin class ngayon dyan? Ayan. So, yung ating shear strain. So, dito po class, which is yung gamit natin is gamma. Ayan, yung change in, ayan, angle or angular. Ano po, yun yung ating shear strain. From its original position, and then dun sa kanyang final position, so nag-create siya ng angle dito. Okay. This figure above shows the shear strain that is developed due to the shearing forces. Ayan, or shearing force. The change in angle, okay, the change in angle daw class at the corner of an original rectangular element is called the shear strain. So katulad yung pinakita natin kanina, ano po, na siya ay nagbago ng shape, ano po, dun sa corner, nagkaroon siya ng displacement. Ayan, so it is expressed and is expressed as yung gamma natin or yung ating shear strain is equals to the, yan, yung ating delta dun sa ating shear, okay, or yung ang change, ano po, sa angular, ano po, ayan, over ng ating length, okay, or yung ating original length. So for illustration class, let's take a look at this example. Let's say class, we have this body, okay, and then originally siya ay at 90 degree, okay, and then we have this fixed base here. So class, di ba, alam natin na dito sa ating body na to, siya ay nagkaroon ng force here. Ano po, yung ating parallel force which develops shear stress. Shear stress is equals to force over ito yung area niya. And then, upon applying the shear force na ito, so nag-create siya ng displacement dito from this original position up to that final position. And then ito yung class yung kanyang displacement. Given na tayo ay merong fixed base here. Ayan class. So, di ba ito yung ating displacement? Ngayon class, ito yung pag-usapan natin, yung theta, okay, or yung, let's say, gamma, or ito kasi angle. So, yung change in angular. Ano po, kaya ginamit is theta. So, ang shear strain daw is equals to the tan theta. So, ano ba yung tan theta natin class? Di ba ang tan natin is opposite, tapos yung ating adjacent, ano, o yung TOA. So, opposite at saka adjacent. So, ito siya class. So, opposite over adjacent. So, ano yung nasa opposite niya? nung angle na to at saka yung nasa kanyang adjacent. So, doon po nanggaling yung ating formula class na delta sub S over ng original length because yung ating shear strain is also tan theta. Okay? Wherein tan theta is equals to opposite over ng adjacent. And then, ang opposite at adjacent side is ito. So, yung ating delta S and then yung ating original length. So, that is the formula. That's why we get this, we have this formula for gamma or for shear strain na delta S over ng original length. Ayan. Again, shear strain is a dimensionless quantity katulad ng ating napag-usapan sa axial deformation or yung normal axial strain. So this shear strain is also a dimensionless quantity. Okay? It is expressed in radian or degree. So radian kasi because class siya ay napakaliit na value talaga. So kung talagang ating kung sa madalit sabi class talaga is ang deformation na ito or yung strain na yun is napakaliliit na po. Very small values. Ano po yung ating strain na yan. Kaya siya ay ina-express lang in radian or kung may problem na nagsasabi na express natin degree. So, pero usually yan ay naka-radian measure lang po kasi napakaliit lang ng value talaga niyang strain yan. Pero napakahalaga nun sa ating system. Ano po, so ganyan. Kahit napakaliit na value, ay ang laki ng nagagawang sabihin natin is delay or maaaring maging cause ng problem sa isang system or sa isang structure. Kasi napakahalaga sa isang structure or sa isang, halimbawa, sa isang rotating system na ayos yung kanyang alignment. Okay? Especially sa motor, sa generator, and then also sa mga building natin, napakahalaga ng alignment. Kaya dapat ay properly aligned siya at naiiwasan or wala talaga siyang strain. Ano po? Or yan. Deformation. They are expressed in, yan, meron pa nga class na in-express siya in microstrains. Sobrang liit, so para lang makita yung value talaga, naka-microstrain siya. Ayan, class, pasok naman tayo ngayon sa sign convention. So, dito. So, napag-aralan natin yung definition niya, yung formula niya, ano po, yan, patungkol sa strain. Ayan. So, ngayon, pasok tayo ngayon sa sign convention. So, we have class a positive value for shear strain and a negative value for shear strain. So, ngayon, pag-usapan natin kailan ba siya positive value at kailan siya negative value for the shear strain. Okay. Pag-usapan natin pag positive. So, positive value for shear strain. A positive value for shear strain means that the angle between x and y axis decreases in the deformed object. Yan. So, yan yung ibig sabihin ng positive value natin. We will have or we can have a positive value kapag lumiliit yung angle sa ating deformed object. Okay, so ano ba yung ibig sabihin yan? Para mas ma-appreciate natin, so ito yung ating illustration. Ayan, class. So, originally, class, ito siya. Ano po? Right angle siya. Ano po? O box or rectangle. Ano po? Due to the shearing force, so nagkaroon siya ng shearing force, subjected sa shearing force, yung angle ngayon nitong ating object na to or ng body na to is nag-decrease. Okay? nag-decrease siya. Let's say, naging from 90, naging lang siya, naging 65 or 50 or 75. So, kung ano mang gusto ninyo. Sa madalit sabi lang ay nagkaroon siya ng pag-decrease sa kanya, sa object na to, which is the deformed body, okay? Or the deformed object. Ayan. So, kaya class, nagkakaroon tayo ng positive value dyan because originally, di ba, we have 90. Ayan. Ayan. So, kasi ang formula natin class dito sa ating shear strain, ano po, is yung original niya, syempre, yung original natin dito nga. Ayan. Kaya siya nagpa-positive is because, di ba, originally is 90 siya, 90, and then maminusan mo nito. Ayan. So, ano makukuha natin? So, ito minus ito. So, yan. Makukuha natin yung value, which is positive because we have a 90. Ano ba? Ito, 2 pi kasi naka-radian measure to. So, yan. Kaya, we have the positive. Ano po? Parang nga lang siyang contradicting kasi nag-decrease ka nga tapos sabihin mo is positive value. Ayan. So, kaya siya nag-positive because, yun nga, 90 minus yung ating decrease angle. So, makuha natin is positive value talaga. Okay, so that's it for our positive value ng shear strain. Then next class is yung ating negative value for shear strain. So, kung yung kanina, nag-decrease, ito naman, yan. The angle between X and Y axis increases. Ayan. So, tumaas naman ito class when the shear strain has a negative value. Ayan. Kung makita natin, kanina, nag-decrease yung angle ng deformed object natin. So, siguro ngayon, alam nyo na, may idea na kayo kung anong nangyayari. Siyempre, mag-i-increase siya or tataas siya ng higit sa 90. Okay, so initially, we have 90 degree here. Okay, or pi over 2 since it is in radian measure. So then class, nagkaroon ng increase sa angle. Let's say, for example, it is from 90, it become 110 or 120. Just for example, so yun. So, and then, pag minus natin sila, so pi over 2 minus kung ano mga angle yan. So, technically class, we will get the negative value. So, yun po sinasabi na we will get a negative value for shear strain because, ayan, nag-increase yung kanyang angle or nag-increase ang angle ng deformed object natin. Sa halip na siya ay lumiit, sa palaki siya. Ayan. So, contradicting din ito. Tumaas ang angle mo, naging negative naman ang iyong value for shear strain. So, okay, so that is the sign convention of a shear strain. So, next class is the formula. So, we have the formula. Yung una nga nating class, di ba, ang shear strain is equals to tan theta. Ano po? So, tan theta wherein yung delta S is equals to the original length L. Ayan. So, and ito pa yung dagdag. Yan. So, makukuha din natin ating shear strain sa pamamagitan yung katulad ng ating nakitang illustration kanina. So, pi over 2 minus yung theta prime natin. Or yan. At tandaan nyo, class, sa pag-solve ng problem with regards sa ating shear strain, set natin ang ating calcu in radian measure. Okay? So, pero kung ni-required ni problem na ang sagot mo is naka-degree, so i-convert lang natin from radian. Pero initially siya ay naka-radian measure. Okay, radian to degree. So, radian to degree is, times mo lang yung value mo ng radian na nakuha times 180 over pi and then you will get the value in degree. Okay? And this one class, ano po, so, yan, naggamit din natin to sa may mga problem kasi na dalawa yung kanyang dito yung change in angle, so to get the total, so which is yung ating shear strain. So we first get the value of yung gamma 1 and gamma 2, and then we sum up to get the final value or the total value of ating shear strain. Okay, so that class is our formula. And then next is Hooke's law on shear strain. Okay, the definition. So the ratio of the shear stress tau and the shear strain gamma is called the modulus of elasticity in shear, or the shear modulus, or ang ibang tawag pa class is modulus of rigidity. And it is denoted as G, capital G, and ayan, it can be expressed in, or the unit is MPa. So formula, ayan, so yung ating G is equals to tau over ng ating gamma. Okay? So just like yung ating, naman, kung i-relate natin sa axial deformation, or yung ating normal axial strain, wherein nga yung ating epsilon is equals to the gamma, or sorry, sigma over ng ating E. E is equals yung ating modulus, capital E is equals to gamma over ng ating epsilon. Yan, yung ating strain. Okay, yung ating axial strain. So same here, nag-iba lang yung ating ginamit na symbol. So G for shear modulus, tau for the shear stress, and gamma for the shear strain. Okay? And then the relationship between shearing, deformation, and the applied shearing force is equals. So yung ating delta S is equals to BL, which is yung ating V is the shearing force, and L is the length, okay? And then A sub S is the area, okay, ng ating nung area or yung cross-section area sa shear. And then G is yung ating modulus of elasticity in shear, or shear modulus. And then equal din siya sa ating tau, which is, kasi yung tau is equals to, diba, ito yung ating shear stress. Ayan, equal kasi siya sa B over ng ating area doon sa ating shear. So tau L is equals, or over ng G. Okay, so that is our formula, okay, for Hooke's law on shear strain. Ayan. So yun, nasabi ko na per N, and yung ating length, pwedeng mm or inch, since sabi ko nga sa inyo, napakaliit naman ito. So area, pwedeng inch squared, mm squared. So shear modulus and PA, shear stress, PA for M. Ayan, so that class, yung ating mga theories, formulas, and yung ating mga concepts with regards sa ating shear strain. So let's now proceed to our problem solving. So i-apply na natin yung ating natutunan na mga concepts and formula dito sa ating problem. So for sample problem number 1 class, so a thin rectangular plate is uniformly deformed as shown. So ito yung class. Ayan. Determine the shear strain at P. So saan ba yung P? So ito, yan. Ito yung point P natin. Express your answer to micro region. Okay. So ito yung ating given. So yung ating delta sub 1, so ito class, 1 over 16 inch. And then yung ating delta sub 2 is 1 over 8 inch. As you can see class, we have two shear strain dito. So di ba nakita natin yung formula natin kanina pagkaganto, so we will use yung gamma sub 1 plus gamma sub 2 since dalawa lang naman to. Yan. At point P. So dito kasi yung tinatanong. Okay, so ayan, I hope na alam niyo ang gagawin natin. Ano po? Ayan, so bring your ready your pen, your calculator, and then your clean sheet of paper, and then we will solve this. Okay? So for ayan. Solve na tayo. Okay, for the given class, lagay muna natin yung ating mga given. So given, so yung ating delta 1, which is 1/16 inch, at yung kanyang length here is 25 inch. And then yung ating delta 2, which is 1/8 inch, and then yung kanyang length 42 inch. Okay? Since yung ating formula kasi for shear strain, okay, so since dalawa to, the shear strain sub 1, shear strain sub 2, and then we will get the total shear strain mamaya pag isa-sum up natin. So, di ba yung shear strain is equals to gamma, or sorry, gamma is equals to delta over ng original length, which is, ayan, so yung ating L. Okay? So, ngayong class, substitute na natin yung ating formula, or yung ating mga value na ito. So, ayan. Required nga natin is yung ating gamma at P. So, or yung ating gamma total. Kasi dalawa yung ating yung ating angle na napuo doon. Okay? So, we will get the total. Okay, the formula to be used, ayan, gamma 1 plus gamma 2 is equals to the gamma that we are, ito yung ating required. Okay, for the solution class, okay, let's start finding the gamma sub 1. Okay, so again, yung ating gamma sub 1, di ba yung ating gamma is, or yung ating shear strain is equals to tan theta or tan gamma. Okay, so tan gamma sub 1 is equals to opposite over ng adjacent. So yung ating opposite, so tingnan natin dito. So opposite natin is yung ating, ayan, yung ating delta S or delta sub 1, which is 1/16 inch. And then yung ating length or original length natin dito sa part na to is the 25 inch. Okay, class, so we will cancel the unit, okay? And then to be able to get the value of gamma sub 1, ayan. So, ita-times lang natin siya, or ayan, ita-times natin ng arctan or tan inverse para mag-cancel yung tan natin dito. And then, doon naman sa kabila magta-tan or arctan siya. Okay? And then, upon inputting ito sa ating calcu, so we will get this value. So, I hope na nagkawa rin kayo dyan. Ayan. Ito po yung ating makukuhang value. So, naka-region measure siya since tayo and to solve under tayo ng shear stress. So, shear strain. Yan. So, naka-region measure po tayo. Okay, so we get, now we have this gamma sub 1. And the next one is finding the gamma sub 2. Okay, we need to get the gamma sub 2. Okay, same procedure class. So, tingnan lang natin, dito naman tayo. So, at point P, gamma sub 2 naman tayo. So, tan gamma sub 2 is equals to opposite, which is yung opposite niya is yung ating gamma, yung ating delta 2 na 1/8 inch over yung ating original length, which is 42 inch. So, cancel the inch, and then, same procedure to eliminate this tan. So, we apply the tan inverse in both sides, and then magkakaroon tayo ng tan or arctan, okay, dito. And then, upon applying yung ating tan inverse, ito. So, we will get this value for gamma sub 2. Again, naka-region measure tayo, class. And then, class, now, we have the gamma sub 1 and the gamma sub 2. we are ready to sum these two to get the final answer. Ano po? Yun yung ating hinahanap. Okay. Gamma is equals to gamma sub 1 plus gamma sub 2. And then, ito yung ating value, okay, na nagka-radian measure. And then, upon adding, so we will get this value. Ayan, na nagka-radian measure. Eh, ang sabi sa problem, ay expressed in microrad. Okay, so 1, 2, 3, 4, 5, 6. So, dito siya papatak. Ano po? Since yung ating micro is times 10 to the negative 6. Okay, so, ayan, input, i-an nyo lang yan sa calcul nyo po. And then, we will get this value, 5476.1765 microradian. So, naka 4 decimal po ako. Okay? So, that is our answer. Tingnan natin kung tama ba yung ating sagot. Ayan, check natin. Ayun, so tama naman tayo, class. 5476.1765 microradian. Okay, so that is our sample problem. Number 1. Ayan, so next problem, class. Sample problem number 2. Find the shear strain at a B. Okay? Ito, madali lang to, class. Since itong ating, kung makikita natin sa ating figure, naka-fix lang to. Ayan. So, meaning to say, ang maaaring mag-adjust lang niya, ito. Ayan, tsaka dito. So, kung ma-adjust dito, syempre, yun yung maging adjustment niya dito. Okay, so, given the following data, express your answer in degree. So, ito yun, class, naka-degree. So, we need to convert from radian to degree. Ayan, so ito yung ating given, class. So, at point A, at point B, so makita na naman natin, the same naman kasi yung in-adjust niya dito sa B is the same amount or the same angle na mag-a-adjust din dito sa A. So, ayan nga. So, para siya na 3 mm, 3 mm, and then 150 mm. Okay? So, anong gagamitin natin? Ayan, tingnan natin kung ano bang ating gagamitin. Since ito ay fix, so madali lang to, class. Okay, so ito yung ating given. Ayan. And then, ano ba yung ating required? Yung ating gamma at B. Formula to be used. Ayan, so tan theta. Since, ayan, gamma is also equals to tan theta, or yung ating shear strain is equals to tan theta. Solution, finding the gamma is, yan, tan gamma. Okay, in class, wala itong gamma sub 1, gamma sub 2, since, ayan, ano po, nakafix naman yung ating body, and at the same time, isa lang naman yung nasa point B. Isa lang naman yung ating angle or yung ating deformation sa angle doon, o yung change in angle. Yung change in angular change doon. So, ayan, substitute na natin. Opposite niya, okay? Opposite is yung ating 3 mm. Okay? And then yung kanyang adjacent is 150 mm. And then, class, to get or to eliminate the tan here, so we apply tan inverse or arctan. Ayan, so now we will have this gamma is equals to arctan 3 over ng 150. So na-cancel na natin yung ating unit, which is mm. And then we will get this one, class. Ito naka-radian measure na, class. Kaso nga lang, ito daw is naka-radian. Ang kailangan natin is naka-degree. So i-times lang natin siya by 180 over ng pi to convert it into degree. And then, class, we will get this 1.1458 degree. Okay? So that is our angle or yung ating shear strain. So check natin kung tama ba yung ating sagot. Yes, so yun, tama naman. Okay? So we get this 1.1458 degree. Okay, class, that's all for our shear strain lecture. I hope that you learned something from this tutorial, and don't forget to share, like, share, and subscribe for more tutorials. Thank you. Thank you again, class, and to God be all the glory. See you sa next tutorial.